What's up, my fellow turkeys? This is Creating Electronic Music with ChucK. In our last video, we talked about oscillator sync, and I showed you how to make LFOs and also how to do FM synthesis. In this video, we're going to talk about classes and the way to make your own custom objects in ChucK. Before we can go too far into talking about classes, we need to talk about scope. What is meant by scope when you're doing programming? I've got here 3 files called Alvin, Simon, and Theodore, and I'm going to use these to illustrate these concepts. The place where you've already seen scope in action in ChucK is inside for loops. So if I were to say like for 0 goes to int I, and then I is less than 10, and then I plus plus, and then I will, I'll just do, and I'll put I in here, save it up, and I'm going to ChucK this file, and it did 0 through 9. It did 10 things. Now, if I were to put I right here and try to ChucK that, save it up again and run it again, let's see what happens. The script fails to compile, and the reason why is because I does not exist down here. It is scoped to this for loop. It is defined here, and then when it hits this second angle bracket, it is no longer part of your ChucK script. For that reason, I can do this again, and it'll just do the whole thing again. I'll save it up, and it just printed them twice. Were I to put this inside here, we'd get results that we might not like. In fact, I think this won't work. Oh, interestingly, that did work. Oh, they got mixed together. Interesting. Okay, so you got weird results when you try to do that. But what you should do if you're having a loop within a loop, as we said before, is you want to have a different inner variable so you can get more predictable results. So let's try that. So now you got a predictable output. It ran each of these things 10 times. Okay, so we can see how a scope works there. Oh, in this case, each of these J's is scoped until this loop exits, and then it's destroyed, and then it starts up again. And then finally, at the end of this loop, there's no more J's, and at the end of this loop, there's no more I's. So that's how scope works inside a loop. Functions work the same way. If I were to say like fun, void, do stuff, and I would say like, let's say a string, I'll go say, oh, hey, string stuff, and I'll just eliminate this. If I say, put stuff in here. Oh, no. And then I can do stuff here. If I run this, it says that. But if I were to say, try to print stuff itself, there, then it's going to get mad because stuff doesn't exist right there. Yeah. Because the variable stuff is defined inside these brackets, and it's destroyed when it reaches the closing bracket. Okay. So that means that variables are scoped in ChucK, and they are generally they exist either at the script level, or they exist at the function or loop level. So they exist inside these brackets, or if you define them outside the brackets, I could say string stuff to hi. And I could say this here, and it would work in both places. So it says it twice, right? So that is a brief introduction to scope, and the reason why I need to explain that is because we're going to talk about classes now, and the way that classes work in ChucK uses scope in an interesting way that makes some things possible, but you have to think about scope while you're making your classes. Okay, so now onto the class stuff. What is a class? ChucK is what's called an object-oriented language, which means that the variables can be what's called an object, and objects can have like inner behavior. So you've seen things like you got yourself a sign ask. We'll call that ask. Goes to the DAC. So right here, we've talked about this before. A sign ask is a type, and this is the object of that type, right? You can, if you want to, make your own types in ChucK, and I'm going to show you how that works. So you can say, I'm going to say private class writer. And inside writer, you can make yourself a function, and I'll say do stuff again. And we'll say we'll just print hey to the console. We'll say inside writer dot do stuff. So if I were to run this, nothing would happen because there's nothing outside the class. But if I were to say I want a writer named A for Alvin, and then say A dot do stuff, then it printed inside writer dot do stuff. So that tells us that I can make my own type, called it writer. I made an object of that type, and then I called a behavior that I defined inside that type, which in this case it's a function called do stuff. I can also do things like create member variables inside there. So I could say like string stuff to write, and then in here, I'll put stuff to write. If I save this up and run it, let's see what happens. It's just an empty string, but if I were to say, I changed it. Chuck that to a dot stuff to write, and then do stuff. So what happened there is I made an object of the type of writer. That object A had its own inner member variable called stuff to write. I changed it to stuff to write, and then I called it. And now and then I was able to print that to the screen, to the console. Okay, so why did I type the word private here? The classes in ChucK can be either private or public, and this is the part where the magic happens. If I were to make this public, it will continue to work in the same way here. And if I chuck it here, you're going to see the same thing again. That's fine. Now, let's jump over to the Simon class. There's nothing in here. I'm going to say writer S dot. So it's called stuff to write. Yeah, stuff to write. Stuff to write. And ChucK, this is Simon. To that. And then do, what did I call it? Do stuff. S dot do stuff. Let's save it up. Now let's chuck both Alvin. Well, let's chuck Simon.ck just to see what happens there. I saved it up. Yep. Undefined type writer and declaration. Okay, so that didn't work. Now let's chuck both Alvin and Simon. Let's see what happens. Alvin typed, I changed it, and Simon typed, this is Simon. Now, why did that work? And this is part of the stuff that's kind of interesting for ChucK. When you define this public class writer, then all other files can use it, and they all get the behavior for free that you defined in here. Now, what is the scope? And this is the part where you have to wrap your head around it a little bit. I'm going to do it differently here. I'm going to chuck Simon and then Alvin. And what would you expect to happen here? I'm going to run them. Simon blows up because writer doesn't exist, and then it works in Alvin. So what happens is that Alvin creates it and puts it in what's called the public namespace, and that exists inside the ChucK VM. When you run this ChucK command, it starts up a ChucK VM. The Alvin script defines the class called writer, and then the Simon class is then able to use it. But if you do them in the opposite order, then it didn't exist yet when Simon ran, so it can't run without it having been defined in that public namespace. Okay, so we can also we can still say a private class called writer inside this class called Theodore, and we'll make a function void do stuff in here, and that's just going to say, hey, I'm Theodore, and then we can chuck all three. Oh, I didn't use it, so I'm going to make writer t dot do stuff. Try it again. So that was fine. Were I to try to do that inside Simon, make a private writer, private class writer. Let's just save it in here. Try to run it, do it again. It's going to error out. Simon didn't work because, oh, maybe it did work. Oh, interesting. I was not expecting this to work, but it seems like maybe it will. So it looks like I can do interesting. So that means that if you do a private class, then that will get used rather than the class that's in the public namespace. So that's good to know too. Okay, so why would this ever be useful musically? Well, for one thing, you can make yourself an interesting class that does interesting stuff and use it in other files, right? So you could have a file that, like say for example, we wanted that thing that cut up breaks to be something that you can use in any file. We can just define that in its own file, and then at the beginning of our ChucK script, call that file. And then if you define it as a public class, then all of your other files have access to it. That's one piece that's interesting. So that you can build up your own software that you can reuse again and again. So right there, that's pretty useful. There's also a weird sort of quasi-magical element to ChucK public classes that I want to show you now. I'm going to get rid of this here. It doesn't work with strings. It only works with really simple types. Like it does work with ints, and that's what's important. It works with ints and floats. Rather than using strings, I'm going to make an int. And I'm going to call it int, and I'll call it number to write. And we're going to have to change all these. So if I run all these, then you would expect it to go 1, 2, 3. Oh. What'd I do? That should be a number to write. This is part of why I don't do these things live. But I'll have lots of edit. That'll be fun. Okay, so that's fine. I think this is fine. I think this is fine. Let's try it again. 1, 2, 3. Now, there is a keyword called static. And so here's what's interesting about static. I'm going to delete this. And I'm going to delete this. Save this up. We're going to run it again. Now, in Simon, it just does stuff. And this writer is a new writer. And this writer T is also a new writer. If we run this again, 1, 1, 1. Now let's do s dot number to write, and we're going to chuck 2 to that. What are you expecting to happen right now? 1, 2, 2. So what happens is it calls Alvin, it sets the number to write to 1. Simon comes in, changes the number to write to 2, and then when Theodore gets it, the number is still 2. What that illustrates is that if you make a public class with a static member variable, which is what this is called, static member variable, that member variable is accessible to all of the objects that have that type. They all share that state. that has a couple of ramifications. For number one, this was a surprising thing for me. I was not expecting to see that in a programming language, because like I feel like if you're to use that kind of thing in production programming for other stuff, it would introduce just lots of bugs, because it seems like shared state like that sounds very scary to me from a programming perspective, but it is really useful from a script writing perspective, and we're gonna see why here in a couple minutes. One thing that we mentioned in the video about scores is that it sucks that you have to define the BPM in every file. And this is how you get out of that. You say, let's say in Alvin, we're going to say public class BPM, and we're going to say static int or float. How about float? Tempo, and then we're going to call this thing, we're going to say 120 the tempo. Oh, I gotta make the instance. So BPM a dot tempo if I say BPM S, and then I print S dot tempo. Remember, to access things, you gotta do that. So what we can see here is that Simon is able to use the tempo that was defined in Alvin, and we only needed to use it in one place. If we want to do the same thing in here, save it up, and note that I'm calling a mess in both of those, but that's okay. It doesn't actually matter what you call them, because the actual variables are scoped to these strings. The objects themselves are not strings, but scripts. The objects themselves have a script scope, but the class itself is in the public namespace, and that class has static member variables. So both Simon and Theodore were able to report on what the BPM is, even though it was defined by Alvin, who never said what it was. I'm going to stop for a minute so I can build up some musical stuff so you can see ways that this can get used. I've taken a little time and I've turned Alvin, Simon, and Theodore into ChucK files that play three different things. And they all have their own private class called Chord Provider right now. And they all work the same way. So in Alvin, let's just go down this class. Class? This is not a class. Let's go down this script. Inside the script, we have a private class called Chord Provider. And all this does is it's got two members, one called chord and one called position. And then I get an instance of that chord provider in Alvin. It's called A. Next, I set up my signal chain. So I've got a sine oscillator going into an envelope, and that goes into a reverb, which then goes into a pan, which goes to the DAC. I have the envelope going into a delay. I've got the mix for the reverb. I've got a duration of a beat. I've got setting that envelope, setting the oscillator gain. I set up the delay parameters here, and I chuck the delay back to itself. I've got the definitions of a major and a minor chord. I set the offset, and then I just blip around in this thing. Note that I'm using the position from my chord provider here. I called this chord provider A for Alvin. And I use the position for that here, and I also use the chord from that here. Now let's hear what Alvin sounds like. So that's Alvin. This is Simon. Simon's got another chord provider defined inside him. It does the same thing, and he's got an instance of that chord provider called S. He's got two square oscillators, both going into a low-pass filter, and which then leads into an envelope generator. I've got the gains for those. The low-pass frequency is set to 400. It's got the definition of a beat. I've got the offset defined, and all this does here is come up with a sort of a jumpy rhythm. Let's hear what Simon sounds like. All right, so also this one is using the chord provider. Note that although it gets a chord, it's only ever using the first member of the chord array. It doesn't jump around in the chord array. I always use that first one because we're going to assume that that's the root or the desired note that the bass would play, and then this gets the position just like the other one did. Okay. Now let's jump into Theodore. Same thing. They've all got private classes of chord provider, and this has got another function called play note, and inside that we've got an LFO that's going to an oscillator. This is using the oscillator sync idea that we talked about in our previous tutorial. That goes into another low pass frequency filter, and then we've got another envelope going, then that goes into the DAC dot left, and then the envelope goes to a delay, which goes to the DAC dot right. Set up that delay with some values, set up the LFO, set up the oscillators, and then we're just setting up, basic values so that it sounds good, and then kicking the duration to now, so that comes in as the note, the position, and the duration. Note that those are not using the chord provider instance. They are just using the ones that are being fed in via the parameters to this function. However, the thing that actually does the work of our ChucK script is this while loop here. And so what that does is for every member that's in the chord, which is the chord provider instance chord, it's going to do something for every single member of that array, and what it does is it sporks a new shred that plays the note, and that does use the chord, and that does use the position from that chord provider instance. So then it calls the play note, where those things are fed in here, and then so what that gets you is you can have a array of any size, and it will play the number of notes that are in the array, and that's why you would bother to do this sporking situation that I've done here. Okay, so let's hear what Theodore sounds like. Okay, now let's play all three of them together so you can see what they all sound like. Okay, so it sounds pretty nice. Now, here is the part where our public classes and static variables starts to become useful. So let's now comment out each of these private definitions of what a chord provider is. But continue to use an instance of chord provider, which would not work if we ran it right now. Let's try it because it'll say that what's a chord provider. Yeah, they all failed because of an undefined type chord provider. Now we're going to go to a file here that I'm calling score. We talked about scores before. I'm gonna dump into score another chord provider, and this one's public. So remember what that does is it means that there's a class A public class is visible to everybody that's running inside that ChucK VM. He's in what's called the public namespace, or it's what's inside the public namespace. And what they contain a static int array called chord and a static int called position. And remember what we said is that if they're static, then they are shared by all other instances of that class. So if this person here, chord provider CP, has these things, then and they're static, then chord provider A in this class, or in this script, chord provider S instance in this script, and chord provider, oh, I also called it S here. It should have been T if I was going to go by my own system. Let's actually do that. Just for consistency's sake. And so now we define it in here, and we've got this chord and this position defined in one place. Let's play the score file and see what we get. All right, so I played for 1 bar and then it stopped. Now, here's where it gets a little bit more interesting. So well, that was interesting, but here's where it gets even more interesting from a musical perspective. So if we wanted to have the music change, like say for example we wanted to use more than one chord in a composition, for example, then we could go into each of those files, and we could, if we were doing it without classes, we could say, okay, well, I'm going to go into Alvin, and on bar 2 I'm going to change the chord, and then I'm going to go into Simon, and on bar 2 I'm going to change the chord, and do some sort of bookkeeping in each one of those scripts. But because we have the public class chord provider and the static variables within that, we can use that shared state to move those things around. So now what I've got here is I've got, let's say, I'm gonna remove these after these, and you're gonna hear some more things after this, but I'll uncomment these a little bit at a time. So we're going to leave the chord the same for now. And we're just going to change the position and go 1 more bar. So what we heard there was that the position changed in all 3 files at once. We were able to chuck that 5 to the position in the CP, which is the instance that's inside this score, and thus it was radioed out to to all 3, Alvin, Simon, and Theodore, because they all had members that were also chord providers, and so they had access to those static members. So that makes it so that you can just play around with your chords. Go a little further. Let's see what that sounds like. We're going to change both the position, and in this one we're going to change the position and the chord, and in this one we're changing just the chord, and you can hear how that sounds. And in that last one it became a 7th chord because I added another member to the chord thing, and recall that because our Theodore has got the capability of sporking as many shreds as it needs to play the chord, that it was able to use as many notes as we wanted to put in there. And then just for fun, I wrote a little bit more. You can hear the whole thing. So that is one way that you can make your life a lot more convenient using classes. I'm going to go a little bit further. I'm going to design another thing, and I'm going to stop the recording so that I can figure out how it works, and then once I get it figured out, I'll show you. Okay, I made another public class, and I called it Chords. Now, as you can see, what we have here is what we had before was if I wanted to define a chord in my score, then I would make the array right there, and I would say which notes I wanted to be in that chord, which works fine, but it's not the most readable thing in the world. And so if you don't want to just define an arbitrary chord at that moment, you just I want a minor chord, then you can do it like this, and then I used it in my score like so. So let's say I've got my position, and then instead of having the array, I've got to use, I called it right here. I made myself a member called Chords that is of the type chords, which is defined in this other ChucK file. And so that way, at the first bar, I just use a minor chord. Second bar is also a minor chord. Third bar is a sus4 chord, and then the fourth bar is a dominant 7 chord. Then we're back to minor, dominant 7, back to minor, jump up to a major 7 chord. Then we do our suspended 4 chord again, back down to our dominant 7 chord, and then the thing ends. So you can hear how this sounds. So you can see that all worked. Now, previously I'd had my chord provider defined in the score file. Now it's not here. Now it's in its own file, which is right here. All it's got is this class here. I've also got a chords file, which is all by itself, and then they both get used. Sorry, I have to apologize for my kids are screaming in the background. But they both get used in the score file, but they're not. Anyway, where was I? So they're just gonna keep screaming. Oh yeah, that's where we were. So they are both using those things in this file, but how do those get created in the first place? The creators of the ChucK language in their book, they recommend this pattern here, which is to have a file called initialize.ck. And what that does is it kicks the files that create your classes that you need in your public namespace, and then you kick your score. And that guarantees that by the time the classes or the scripts that are inside your score get used, the classes that you want to be in your public namespace will be available. So that is good practice according to them, and who am I to say anything different? We now have a chord provider that's available in the public namespace. See, it's public, and it's got its static members, making those static members available to all other chord providers. And same deal with chords. All these static members will be available to all instances of chords, and then the score gets a chord provider, which, number one, can be used, but also is used to set the position and the chords for all the other chord providers that get used in all the other scripts, aka Alvin, Simon, and Theodore. And then the chords class is just here providing a convenient way to choose chords to send to that chord provider's chord member. We're going to do one more thing. We're going to define one in real time, and we're going to call it BPM. And this is one I'd use for a different project. Okay, so I'm just going to copy and paste this whole thing. And I'm going to make a new one inside I'm going to paste this in here. I'm going to save it alongside the rest of these things. I'm going to call it bpm.ck. And what it does is it takes a beat, which this is going to be the actual tempo And if you do that, then it's going to set the values of quarter note, eighth note, and sextuplet note. And it's also got a my duration thing that you can use in case you want to get a random duration. We're not going to use that piece for this, but let's use our BPM CK thing in here. So now we're going to add that to this. We're going to use it in the score. And rather than using beat everywhere, so we're going to define the, how does that get used again? It's BPM, we're going to check 120 to BPM tempo. I think that's kind of how that's going to get used. Yeah. And then we are going to use, we're just going to do a find and replace. Instead of using the term beat, we're going to use the term BPM dot quarter. I think we should call it quarter note, yeah. And it really wants to have a bar too. So we're gonna define a bar inside the BPM class as well. And we're going to assume that we're going to have 4 beat bars for now. And then in our score, let's just do another find and replace. And then I believe that this is going to work right now because they all happen to be, yeah. They all happen to use 120 right now, but now we're going to jump back into Alvin, Simon, and Theodore. So in Alvin, where does the beat get set? Right here. So we're going to make a BPM, and then we're going to define the beat as BPM dot quarter note. And we're going to do the same thing in here. Gotta find it. Yeah, there we are. Save it up and jump into Theodore. Save it up. So that's working just fine. Now if we jump back into the score, we now have access to all of the BPM objects inside of all of our scripts. So if I wanted to make this 150, make it 150, try it again. If we wanted to make it 100, or let's make it 80, we'll slow it way down. All right, so now you see how having public classes with static members can be a super powerful way of sharing information around your ChucK scripts and keeping things in sync with each other. You also have the option not to use them if that becomes too restrictive, but you can always just throw more stuff inside the things that you have. So like, let's say I wanted to have some really far out chord. It's a piece of cake. Just throw it in here and then use it in the places where your files are use it in your score file, for example, or you can even use the chords files inside your other scripts if you want to. In this tutorial, we learned about classes and specifically how classes can allow you to share information between your ChucK files by using static variables. In our next lesson, we're going to talk about dynamics.